A very happy and a warm good morning to you all children, and I welcome you for today's learning process. Today we are going to continue with metals and non-metals, and this will be the third class for this chapter. In the first class, to recall, we classified metals and non-metals on the basis of physical properties, and on the last week's class, we have classified elements as metals and non-metals on the basis of chemical properties. Now, today's class, it is an extension of the metals and non-metals on the basis of chemical properties. A few more properties we are going to learn today, which is based on the chemical properties. So, it is a continuation of the last week class, right? So, let us go into the lessons. This activity specifies the reaction between a metal and a non-metal. So, what will happen if a metal reacts with a non-metal? Generally, it's a GK question also. We can blindly say when a metal reacts with a non-metal, hydrogen gas is evolved. Hydrogen gas is evolved, as we have seen the evolution of hydrogen gas in the previous experiments. So, here also hydrogen gas is evolved. And what is the test for hydrogen gas? So, we introduce a glowing candle to the mouth of the gas, and the flame burns with a pop sound. So, if the flame burns with a pop sound, certainly the gas evolved is a hydrogen gas. This is also a GK question. How will you test the presence of hydrogen gas? So, if the flame burns with a pop sound, then the gas released is hydrogen gas. So, now let us go into the activity. Now, look at the diagram at the center. A test tube is being taken and it is clamped in a stand, and already the test tube contains two. One is sodium hydroxide solution. Sodium hydroxide is an alkali, or we can say it is a base, and to it we are adding a small piece of aluminum, and either we can close the mouth of the test tube with our thumbs and shake it well. Then the reaction will take place, and you will feel that something forces your thumbs up to lift your, that means a gas is being evolved. At that time, bring the burning candle near the mouth of the test tube. You can see immediately a pop sound and the candle will begin to burn brightly. So, this is the experiment. So, this experiment has proved that when a metal, aluminum, reacted with a alkali or a base, that is sodium hydroxide, then it releases a gas called hydrogen. Now, let us go through the slide now. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 to 4 pellets of it in 5 ml of water. So, we have to take a test tube, drop 5 ml of water into it, and 3 to 4 pellets. Pellets means it's a crystal, just like the camphor that you are using for the puja. In the same shape it will be, and 3 to 4 pellets of sodium hydroxide. It will be like a salt. You have to take and dissolve in it, and the solution now is the sodium hydroxide solution, and it is a base or alkali. Now, to that test tube, you have to drop a piece of aluminum and bring a matchsticks or a candle on the mouth of the test tube. So, what do you observe? Here, the pop sound is being indicated, and that is the reaction between the metal and a non-metal. So, to conclude, Metals react with non-metals and they release a gas called hydrogen. But generally, non-metals reaction of non-metals with the bases are complicated, and you will learn in detail when you go to class 10. Okay, children? Let us perform another activity and learn in detail with that. So for this activity to carry out, we need 5 beakers, and let us label the beaker A, B, C, D and E, and let us take 50 ml of water in each of the beakers, and we have to dissolve the following into the beakers. So what should be added in the beaker A? There it is there given in the slide. So in the beaker A, copper sulfate and zinc granules. So zinc granules and copper sulfate both are taken, and it has to be dissolved in beaker A. Similarly in beaker B, copper sulfate and iron nail, they are to be dissolved in beaker B. Beaker C, zinc sulfate and copper turnings, these two are dissolved in beaker C. And in beaker D, iron sulfate and copper turnings are to be dissolved. And in beaker E, zinc sulfate and iron nail, both of them are taken. So in short, we have to take 5 beakers, take 50 ml of water in all the five beakers. So dissolve as shown in the table here, beaker A, beaker B, beaker C, D and E. So the chemicals which are indicated here, we have to dissolve it. Okay, and that is the experiment. Let us observe what happens in beaker A. So what are the chemicals taken in beaker A? Copper sulfate and zinc. These two are taken in beaker A. Now copper sulfate, when you look at its color, it will be blue in color. Copper sulfate is always blue in color. And after some time, that means after the reaction has taken place between copper sulfate and zinc, you can find a red color deposit at the bottom. So the blue color would have been disappeared, and you find a red color deposit at the bottom of the beaker. This indicates that reaction has taken place. So in what way is the reaction taking place? So see to the reaction given at the bottom of the slide. Copper sulfate plus zinc gives zinc sulfate plus copper. So copper is displaced from copper sulfate. So copper has been displaced, and that's why we call it as displacement reaction. So before the reaction, copper sulfate was blue in color, and after the reaction we see the red color copper deposits, which means copper has been removed or displaced from copper sulfate. So let us keep this in mind, and we will continue with the further beakers, how they are getting reacted. We will see to the results of the next beaker, beaker B. This slide explains you what is happening in beaker B. Here the heading it says 2, but it should be beaker B. So a piece of iron metal is placed in copper sulfate solution. So copper sulfate solution, as I told you, it will be blue in color, and the nail, it will be gray in color. Fresh nail will be gray in color. So the gray colored nail is inserted into the copper sulfate solution. Now after some time, when you look at the same cylinder, you see in the figure on the right side one, the blue color solution would have turned into light green, and the gray color nail would have acquired some browny deposits over its surface. So this shows here also the reaction has taken place. So here the reaction is between iron and copper sulfate. So iron Fe, copper sulfate CuSO4. After the reaction, it forms iron sulfate and copper is being displaced here too. So iron sulfate and copper. So Fe plus CuSO4 gives FeSO4 plus Cu. So here copper is being displaced, and we also call it as displacement reaction. So in the first beaker we have seen a displacement reaction is taking place. The second beaker also there is a displacement reaction taking place. And let us see the reaction in the remaining beakers. Now, to our surprise, there will not be any reaction taking place in the beakers C, D and E. Now let us analyze why in beaker A and B reaction had taken place and why not in the other remaining three beakers. So to know this, when a reaction will take place, when a reaction will not take place, you need to know the reactivity series. Look at the right side of the slide. You find a list of elements starting from potassium till platinum is given in blue color. So they are being placed in such a way, the potassium is the most reactive element, and down of all, platinum is the least reactive element. So this you will learn when you go to class 10 in detail. Now let us take the three metals which we have taken in the beaker. One is zinc, next is iron, third is copper. So among all this, zinc is the most reactive metal. You can see in the list zinc comes first, then below zinc you will find iron, and below iron you will find copper. So among these three, zinc is the most reactive, and the next reactive is iron, and the next reactive is copper. Of all the three, zinc is the most reactive and copper is the least reactive. Now let us see what is happening in beaker 1. In beaker 1 we have taken zinc and copper sulfate solution. So zinc and copper sulfate. So zinc is the most reactive. So in the reactivity series we have just now seen zinc is the more reactive. That's why it is reacting with copper sulfate and there is a reaction taking place. And in beaker B, iron with copper sulfate. So iron and copper sulfate. When we compare iron and copper, iron comes the most reactive element or metal. That's why here also reaction is taking place. And this type of reaction, as we have discussed, it is a displacement reaction. What is a displacement reaction? You can see it in the slide. Displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. And let us see in beaker C. In beaker C, we have taken zinc sulfate with copper. So compare copper and zinc sulfate. So copper is the least reactive, right? And since copper is the least reactive, it cannot react with zinc sulfate. Therefore, no reaction is taking place. And in beaker D, iron sulfate and copper, the same thing. So copper is the downest of all the three. So iron comes up. So copper cannot react with iron sulfate. A less reactive metal cannot react with a more reactive metal. And that's why here also no reaction is taking place. In beaker E, zinc sulfate and iron nail. So zinc and iron, when you compare, zinc comes first, iron comes next. So iron is less reactive than zinc sulfate. Therefore, here also reaction is not taking place. So a more reactive metal can displace a less reactive element or metal, and that is, we call it as displacement reaction. And a less reactive element cannot react with more reactive element. So that's why in beaker C, D and E we don't see any reaction. Let us see some of the uses of metals, as we have already discussed this point. Iron is used in making machinery, building, car, motorbikes, ships, bridges, etc. So iron has its own vast usage in our daily life. Copper is used in making electrical wires, statues, vessels, etc. And aluminum is used in making kitchen utensils, electric wires, etc. Gold is used in making ornaments. Silver is also used in making ornaments. So these are quite few uses of metals. Now let us look into the uses of some non-metals. Sulfur. It is used for making sulfuric acid, salt of some metals, etc. Then oxygen is used for respiration by living things, burning of fuel, etc. Nitrogen is used for making ammonia, which is used for making fertilizers. Hydrogen is used for making ammonia, which is used for making fertilizers, as fuel in rockets, for welding, etc. Chlorine, it is used to kill germs in water. Iodine is used as tincture iodine, which is an antiseptic. So these are the few examples where we make use of the non-metals in our day-to-day life. Here we come to the end of today's learning process, and by this we are completing the chapter also, metals and non-metals. So only a basic is being discussed, as you are all in class 8, and more about this you will learn when you go to your class 10. With the equations you will learn it. So these basic informations which you have learned will help you a lot when you go to class 10. So remember the concepts, the ideas and the basics in this lesson. Okay, so all the best, children.